All right, guys. This is the last 3 pages of the trig review for the packet we're sending home. Page 5, 6, and 7, I believe. I think that's corresponding pages. I just want to go through how to do a couple of these, and we'll keep going. The first page there is just review, except for one section. First one says, first couple say find coterminal angles, so you're just going to add 360 and subtract 360. Second section, they're wanting you to change that to a radian measure, which we talked about in the previous video. You'll just use that conversion factor pi over 180 and then reduce accordingly. The next one, express the following angles in degrees. So we're not worried about 16 and 20 right yet. We'll talk about that in class next year. That's something that's a radian. And then 13, 14, 15, 17, 18, 19, you're just going to write them in degrees. So that means substitute 180 in for pi and then go from there. 21 through 24, let's not worry about that right now. We'll come back to that in class. That's something that we're going to have to write all the trig ratios using a graph, and we will get to that in class. In calculus, we don't use that a lot in calculus, but we do. Sometimes you may have one like that on an AP calculus test. So I guess my main goal is to review some things that I know that we're going to have to use in calculus, and also that you're supposed to get in class. Okay. All right. 29 through 34. This is where it gets interesting. They're wanting you to evaluate the trig function. If they give you one trig function, give you another one. Find the value of another one. So this is pretty good. You have to use your Pythagorean theorem here some to find the other measures. So just kind of be cognizant of that and go through those. Those are fairly easy. Just be careful on ones that involve cotangent and things like that. Make sure you're reading it correctly. Okay. It goes back to references back to our other videos about what cotangent is and things like that. Evaluate sine, cosine, and tangent of the following. This is all unit circle stuff. Okay. All of these should be on your unit circle, so you shouldn't have to do too much. The only thing you really have to work on is the tangent part. Okay. So if you're working through this and you're going through this stuff, make sure that you refer back to that unit circle. Okay. That was the first page of that. Let's see if I can get to the second page. All right, I have successfully arrived at the second page. So the second page is a little more involved. I say the second page. It's really I think the sixth page of the packet, but the second page of the group of work there. All right, 47 through 50. This is something we talked about in class. You're talking about the inverse. So what this means is, for like on 47, what value of sine gives you square root of 3 over 2. Okay, so you're going to read the table backwards. So they want to know what value of sine would give you square root of 3 over 2. So if you look at your table, you find where sine, or look, I say table, we had a table in class if you still have it. And you look at that and you say, where is sine square root of 3 over 2? Well, square root of 3 over 2 is 0.866. If you're doing this in the calculator, you got to remember those fractions. 0.7071 is square root of 2 over 2, and 0.866 is square root of 3 over 2. So you really want to know where sine is going to give you that value. Okay, so you look at your unit circle and you ask yourself, where is sine square root of 3 over 2? Well, this answer would be 60 degrees. So, hang on, 60 degrees. Because if you type in 60 degrees in sine, that's what you're going to get is 0.866 or square root of 3 over 2. So that's what all of these mean. All of these mean where are these values going to be, what's in parentheses. So you're reading your unit circle backwards. Okay, that's that section. The next section there, 53 through 56 is really right triangle trigonometry, and we're really not going to use that. Okay, so I wouldn't worry about 53 through 56. We'll talk about that if we need it in calculus. We'll talk about that more. It comes available. All right. The next section is find two solutions of each equation. Now, this does go back to the unit circle. So what they're talking about here is, if you look here, they are giving you some constraints here. So they say between 0 and 2 pi. So they're talking about one full rotation of the unit circle. Okay. So let's just do one. Let's talk about this. 57 says the cosine of theta is equal to pi over 2. So they're wanting to, square root of 2 over 2. So they're wanting to know where cosine is going to be square root of 2 over 2. Well, if you look at your unit circle and refer back to it, we know it's going to be an increment of 45 degrees. So we know one answer here is 45 degrees, okay? So the cosine of 45 is positive square root of 2 over 2. Now, you got to remember that sine is y and cosine is x. So that other value is going to be in quadrant 4. So this answer is going to be 315. Okay. So the two places that cosine is going to be positive square root of 2 over 2 are 315 and 45 degrees. Everywhere else it's going to be something different, or it could be negative. Okay, so work through those. Pretty easy. Disregard 59 and 60. Okay, they're kind of arbitrary there, and then I think the rest of them are very relevant to what we're going to do. So if you did the other activities, 61 and 62 should be very easy. And then 65 is just a comparison problem, looking at your other answers for any types of patterns. Okay, so we're really not worried about that. All right, moving along here, the last part, I keep forgetting to hit zoom. The last part is solving trig equations. Okay, now this is not very difficult. I mean, if you can understand some basic stuff, and what I want to do is I'm going to go add another screen, and I'm going to work through a few of these together. Okay, and then we'll go from there. All right, so it's going to be a short pause. I'm going to add another screen. Okay, guys, so what I want to do is I want to look at a few of these, and I wanted to get another screen so it wouldn't be so jumbled up, and then maybe it would look a little better. I don't know. My handwriting on this thing is pretty bad, so I'm going to do the best I can. So here we go. The first one there, if I'm referring back to page 6 here, is going to be 2 times sine squared theta equals 1. So what you're doing is you're solving for theta. So this, like I said, this all goes back to the unit circle. So you're going to divide by 2. So that's going to give me sine squared theta equals 1/2. And then remember, we're solving for theta. So we want to take the square root of both sides. It's just like a regular equation, that we've learned up until this point. So now I have sine theta. If I take the square root of both sides, like this, these cancel out, so I'm left with sine theta equals, well, square root of 1 is 1, and then that's going to be 1 over square root of 2. Well, Can't have that. So we've got to rationalize this. So this will be square root of 2 over square root of 2. So not my answer, but my equation that I'm left with is sine theta equals square root of 2 over 2. And then it goes back to, like I said, the unit circle. Where does theta equal square root of 2 over 2? Well, that's easy. This is 5 degrees. Now, remember this answer, if you were taking a calculus test or maybe even any type of standardized test, what else is 45 degrees? Well, that's pi over 4. So any of those would be a sufficient answer, okay? So those are, one example there, or one way to get that one, okay? So, and let's see here which one we want to do next, okay? So let's go and let's do number 60. Let's see. Let's do 67. Okay, 67 says tangent squared theta equals 3. Okay, so well, this was pretty easy. Take the square root of both sides. So this is tangent of theta equals the square root of 3. And then ask myself, well, where does, tangent of theta equals square root of 3? So we know it's going to be one of those measures between 0 and 2 pi. So let's think about that. Square root of 3. I think we had this one, square root of 3 over 2 over sine over cosine. So what I'm really asking is where are we going to have the square root of 3 on top? Okay. So where does sine equal the square root of 3 over 2? So if you remember that from the unit circle, then you should be able to get this pretty easy. So let's see if it's 60 degrees. So check 60 degrees and see what you get for the tangent of 60. And let's see if that is the square root of 3. So yes, it is. So tangent of 60 is going to be equal to the square root of 3. So that is my answer. So the answer is 60 degrees. Now remember, that's not always the way that they could write the answer. They could write this as pi over 3 because, 180 is pi and 180 divided by 3 would be 60. So those would all be sufficient answers there. Okay. So those are a couple that you could think about on that page. Look at 71. 71 says, where does sine equal cosine? We'll talk about that in calculus quite a bit. I know that my students in the past have really liked that problem. It's very interesting. Okay. All right. I want to call your attention to 69 and 70. And what I want to do is I want to change screens and we're going to come back to, and I'm going to work 69 and 70. All right, 69 and 70. So let's take a look at 69 here. 69 says 2 cosine squared theta minus cosine theta equals 1. Okay, so we are stuck with that one, so to speak. A couple of different ways we could do this one, but we should see that this may work out to be a quadratic. Okay, so this is one thing that I try to get my students to understand, that all this stuff that you used in algebra up until this point is eligible to use in calculus. So I'm just going to move the 1 over here. So 2 cosine squared theta minus cosine theta minus 1 equals 0. And then I'm just going to try to factor this thing and see if we can get this to factor. Well, I know that this is going to be 2 cosine theta in the first position here. No, I'm just using trial and error. And this is going to be cosine theta. Let me move this parentheses over for some reason. I didn't give myself enough room here. So we know that's going to be in the first position. We know that one's got to be positive and one's got to be negative, okay, because we got a -1 at the end here. So what I'm doing here is I'm trying to figure out what goes here, what signs work to get you that factor, okay? So we know they both got to be ones. We know that because the only thing that would give us 1 is 1 times 1 is 1. But we don't know which positive and which one's negative, okay? So here I want a negative cosine in the middle. So I'm assuming that if I say -1 times 2, -1 times 2 cosine, that's going to be -2 cosine. And then if I have a positive cosine, that will work out to be that way, okay? So that is the factorization of that. So if you look there, some of these other ones may factor as well, okay? So, that's one way to think about that one. So now I'm stuck with, how do I solve these two things? Well, this goes back to, just basic algebra. I'm going to solve 2 cosine theta plus 1. I'm going to set it equal to 0. And then I'm going to say cosine theta minus 1 equals 0. Well, this one's easy. Cosine theta equals +1. So you want to know, where does cosine equal +1? Okay, so if you think back to the unit circle, well, cosine is x. Where does cosine equal +1? Well, this answer could be 0 or 360. And the reason you include 360, if you look in the directions there, it does say 2 pi. Okay, so this other one's a little more difficult. It says cosine of theta equals, and I'm going to move this over and then divide by 2, -1/2. So where does cosine equal -1/2? Well, cosine is x, so it's going to be somewhere in the fourth quadrant down there. So cosine equals 1/2. Let me check my unit circle. See, I forget these things too. So let's see. Let's check the cosine of 330. Let's see. Cosine of 330 is, no, that's 0.866. So if it's not 330, it may be 300. So let's try 300 cosine. Yes. And cosine is, but wait, it's going to be negative. So it's going to be over there in quadrant 3 and quadrant 2. So let's see what it's going to be. So it's not 300. So I'm looking for -1/2. I almost forgot my negative there. So let's see. Let's try 2. Let's see. Let's try 150. Cosine of 150. Let's look it up. That's negative. No, it's not 150. So the next one will be, let's see. After 150, go up, that's 135. Keep going up, that's going to be 120. So let's see, cosine 120, and there it is. So it is 120. Okay, and then I got to find the other one. So let's see what that's going to be. That's going to be down in quadrant 3, where 225 and everything is. Let's see, 225. 210 maybe. Let's try 210 cosine. That's -0.866. So that's not it. 240 cosine, and that's -0.5. So what I'm doing, I'm checking mine on my calculator. Like I said, you could use your unit circle. So it's number 69 came out to have 4 answers. So see, these things can have a ton of different answers. Okay. So that was number 69. Okay, number 70. Now, number 70 is a little different, okay? So we've got a couple of different ways to do number 70. I'm gonna write it on the screen first and go from there. I've got secant theta times cosecant theta equals to cosecant theta. Now, like I said earlier, all of your algebra stuff it still holds true here. So if you wanted to solve one of these things, you could use any algebra you wanted. Okay, so personally, what I would do here is divide both sides by cosecant theta, and these cross out. So I'm left with secant theta equals 2. So secant theta equals 2. Well, what is secant? Well, secant is 1 over cosine equals 2. Okay, so if I wanted to know where 1 over cosine equals 2, then I've got to figure out what would give me 2 from a cosine measure. Okay, so let's think about this. 1 over what would give you 2? Okay, well, what would that value have to be? Well, there's a couple ways you could figure this out. You could put an x there and do like this, cross multiply. So that would be 2x equals 1. So 2x equals 1. And then divide both sides by 2. So x would have to be 1/2. So really what you're wanting to know is, where is this 1/2? So I guess what we're asking, this whole question is just asking, where is cosine equal to 1/2? And in the previous problem, I think we exhausted that. Cosine equals 1/2 where? Well, I think it's cosine of 60. So this answer would be 60 degrees. So that shows you one where all of the different algebra skills are being used. So you can use any algebra one. So you can go through the rest of those and work those out. 72 through 74 on that page, 72 through 74. Wait, and we'll probably, well, I say probably, I know we'll do those in class. I know that 66 through 71 are really the ones you need to focus on from the packet, okay? Okay, guys, the last page of the packet is talking about trig identities. And those are very important. We use trig identities a lot in calculus, but we're not going to have the time to go through all of these. So the ones you need to focus on the packet on page 7 is 90 through 98. Okay, those are some basic ones, and I'll take you through one, and then I'll show you how to do that, and then you can go from there. Okay, so number 90 says sine x secant x equals tangent x. Okay, so these trig identities are useful in calculus, especially when we start talking about the last part of calculus with polars and different things like that. And that's really what we want to focus on, is to get you ready for calculus, to make sure you remember these things, because this would have been the last part of, our algebra 3 or our trig class, whichever one you were in. Okay, so these are kind of fun. I really like these. Some people don't like these. I've had students in the past that really, really like these. And these, some people do like these, and that's good, because they can be kind of interesting. They get you in a good train of thought, or how to solve these things. Okay, so we got sine times secant equals tangent. So basically, what you're doing is you're working on one side to get the other side. So if you look at all 90 through 98, it looks like all of them would pretty much be working on the left side. Okay, so I would probably start this one, leave sine like it is. And well, what is secant? Well, secant is, from the other video, 1 over cosine. And then sine x over cosine x is what you get when you multiply these two. And sine x over cosine x is tangent x. And that proves that that does equal the right side. So you're done. So that was super simple. It's basically just subbing in and using some simple algebra, to do that. So, like I said, these are pretty easy. And that was number 90. Okay. So, I'll change the slide and we'll do number 9. Excuse me. And we'll do number 95. Okay, guys. Number 95 says sine x tangent x plus cosine x. I apologize for my handwriting on this, equals secant x. So, like I said, you're going to work on one side to get the other side. Okay. So, here we go. So, I would probably start by changing tangent to sine and cosine. So, now I've got sine x times sine over cosine plus cosine x. So, I'm left with that. Okay. So now, let's see. I can multiply the top part on the first part. So this will be sine squared over cosine plus cosine. Oh no, over 1. Well, I'm stuck here because obviously I've got to do something to make the left side look like the right side. Okay. So I could get a common denominator. And if I got a common denominator, then the common denominator will be cosine. So now this will become sine squared over cosine plus cosine squared over cosine. And then, I can add sine squared plus cosine squared. Well, this comes out to be sine squared plus cosine squared all over cosine. Well, how in the world does that equal secant? Well, if you remember from our trig identities, there's something special here. What is sine squared plus cosine squared? Well, if you remember from the trig identities, sine squared plus cosine squared is 1. So this is really 1 over cosine. And what is 1 over cosine? Secant. And I forgot my x there. I'm bad about that. I apologize. Sometimes I will be working through the problems and I'll forget my x, and then I just put it back in there at the end. That's probably a bad habit. But basically what you did here on this one is you changed tangent to sine over cosine, and then you got a common denominator, and then you added those, and then you had to know that sine squared plus cosine squared was 1, and that left you with 1 over cosine, which is equal to secant x. So you did prove the left side. So like I said, guys, in the packet, you want to work through, or at least know how to do 90 through 98 there. And I know I'm referencing that a bunch. So those are the main ones. 99 through 100, 111. Those are kind of difficult. I probably wouldn't fool with those just yet. Wait till we get in class in the fall, and we'll go from there. So, guys, I hope this video helps. And what I wanted to do, like I said, I just wanted to go through the packet that we sent home and make sure that we understand, what the things are we're going to need in calculus. And I wanted to focus on trig. I know that my students, that's where my students in the past and, present, that's where they struggled the most is with trig, just because we don't use it a lot. And, when we see trig in a calculus problem, we would get flustered or, you know, it would kind of call us aback a little bit, and that doesn't need to happen. You know, we need to be fluent with our trig stuff. So uh, these videos were just so that you guys could just refresh on that, and you know, make sure that we remember that for calculus.